think we better start. Good evening, everybody. I think most people are old hands here, so I don't need to describe the series. Just one housekeeping announcement. October, we realized that the first Friday is Dussehra. So then that will cause problems in people coming and going in the evening. So we've shifted the talk from 3rd of October, which is a Friday, to the 1st of October, which is a Wednesday. I mean, we'll obviously advertise it as such only, but I thought for people who are here, they should know. So without further ado, I'll leave the thing to Dr. Rajivan, who's going to introduce the speaker. Thank you.
Thank you. And first of all, I should thank the center for inviting us for this important lecture. Yeah. And I am very happy to introduce the speaker, Dr. Rathore. He's my senior colleague in the Ministry of Earth Sciences. Now at present he is working as the Director General of India Meteorological Department, the National Weather Agency. And he has a lot of awards and honors to his credit. He's basically, he did his PhD, MSc and PhD from Udaipur University and from Rajasthan and on agriculture, soil science. He's basically soil science scientist, and he joined IMD, India Meteorological Department, in 1980 as a meteorologist. So he's a meteorologist grade 2 and served in various capacities. And in between, he moved to National Center for Medium Range Weather Forecast. It's called NCMRWF. It is in Noida. Earlier it was here, now shifted to Noida. There he was a senior scientist. And there his important job was to integrate the agro-meteorological services in the country. He has done a wonderful job of integrating agricultural services within the ministry, as well as within coordinating with agriculture universities around the country. And now the agricultural service is one of the best services which the ministry is producing it, and it has got good recognition. And mainly it is thanks to Dr. L.S. Rathore for his immense contribution. And he has served in many committees, and for example, he is a fellow of Indian Meteorological Society, and he has been promoting Indian Meteorological Services, Meteorological Society in various capacities. And also he has the recent distinction he has is that he is a vice president of, he was recently vice president of Commission for Agriculture Meteorology of WMO, which is a rare honor of WMO. At present, he is also associated with the Climate Services, which is introduced newly by the World Meteorological Organization. He is the vice chair of that Climate Services. And he has served in many committees and as member as well as the chairman of many committees. And his main contribution is, as I told, is in agriculture meteorological services. And he has produced many research papers, and he has a lot of many students also as PhD students. And he has recently he is a recipient of Lucky Ram Memorial Award, which is awarded by Society for Recent Development in Agriculture. And many things to his credit. I request now Dr. L.S. Rathore to give his talk.
Thank you. Okay. Dr. Rajivan and friends, it's a great privilege to be with you this evening and to share some of the latest developments which have been happening in the area of weather forecasting. And the topic assigned to me by Shobit is to talk about weather and climate forecast and its applications. I would bore you much with the scientific jugglery, but since the topic is scientific, somewhat of scientific jugglery is inevitable, so please bear with me on that account. And to begin with, the both weather and climate, they are two distinct entities. As you all know, that weather is what you experience now day to day, and the average of weather for a long period is what we say as a climate. So I'll touch upon how to, I don't know. Remote hai? It's not happening. Yes. Okay, great. Thank you very much. So I will just, before I come on to how we predict weather, I would like to dwell upon, because before you predict, you need to assess the current state of atmosphere and then extrapolate both in time and in space. And to do so, you need observations. And therefore, I'll touch upon as to how we observe weather and simulate the initial conditions, and then touch upon different services and what are we going to do in future times. I'll touch upon that towards the end. In the recent past, you might have noticed that there is incremental use of meteorological information in various sectors of economy. There is a tremendous jump, and which has primarily come because of three things. First and foremost is there is significant improvement in the quality of information, quality of forecast which is being generated. And this has mainly come from a lot of research and development which has taken place in the area of atmospheric and allied sciences, including oceanic sciences and the infrastructure development, and also better models, and also the capacity to assimilate observations into model to better define the initial conditions. And the secondly, it has come through improved capacity of the user. And first and foremost, because user is becoming more aware, and also because of his economic requirement, because he has to cut the cost, so he do more value-based decision making, and his capacity also to absorb the information have increased over the period of time. And finally, there is a significant improvement in the consciousness about the global change. Everybody, you ask anybody climate change, and everybody, even the rickshaw puller, would tell you that climate is changing, and he will so many things. So the response to this global change is also one of the factor in. Now, since I come from India Meteorological Department, I would just like to share that as to what we do and what we are. Now, we do observe weather and predict weather in different temporal ranges for enhancing the national economy. And this problem basically has three components. First, you, as I mentioned, that you observe weather, then analyze to identify what are different weather systems at given state of time, how are they, have they manifested over the recent past, and then you do forecast, and finally you disseminate information to end user. Whatsoever good is your information, if you are not able to reach out to the user, it has no value. Now, to begin with, I'll touch upon the observing systems, and it is through observations we define the initial conditions. And let me submit that observations are very expensive propositions, and you don't have observations at large space of the Mother Earth. 2/3 are oceans, so practically no observations. Mountains, deserts, poor countries who can't afford the observing systems. So you have some observations here and there, which are again very random. And in order to define the initial state of atmosphere, you does it through numerical models. And when I say models, you really first simulate atmosphere and imagine that you have a mesh around the Mother Earth at different grid points. Say for horizontal, present models we run is about 22 kilometer. And vertically you slice the atmosphere into different layers. So we define entire atmosphere into 64 layers. Now therefore, if you have to simulate atmosphere, you have to define value of each meteorological element, that is temperature, pressure, humidity, wind, and so on and so forth, at each of these grid points. Now, this is a Herculean task, and you don't have observations. And therefore, there are large number of extrapolations. Now, here comes the role of remote sensing observation, which I'll come at a later stage. But at the same time, there is another problem. Because when you run the model, you need global data. You need to have global information. And therefore, you have to have an arrangement with entire country, all the nations to record observations at certain specified synoptic hours and share the information. So therefore, under the charter of UN, we have a specialized agency known as World Meteorological Organizations. We have a very set procedure as to how to observe, when to observe, what to observe, and how to communicate. So there is end-to-end system of taking observations, and then you have to have a very strong telecommunication system for exchange of this data, then processing of data. Believe, huge information, and in the whole process of observations to coding, decoding, communication, large number of errors creeps in. And you have to filter out those errors when you really are ready for assimilating that observation into your model, because if the observations are erroneous, they will make your initial conditions very erroneous. And therefore, there is a huge error which can creep into defining the initial, let alone the forecast. When people often talk that forecasts are not correct, this, that, believe me, there is a very big challenge even to define correctly the initial state of atmosphere. And you cannot precisely do that for the problems I have enunciated. You can't. There is huge amount of error here itself. So therefore, the challenge, first challenge is to minimize this error, to really simulate atmosphere as close to as what is its actual. But still there remains an error. And we have term which we call as predictability. Now henceforth you extrapolate through models both in time and space. As if temperature is now here, then what will be after 15 minutes, and so on and so forth. This error magnifies. So there is what I said, that predictability is the term that there is a theoretical limit to this extrapolation. And in theory, we define that if there is an initial error is x, when it doubles, when it becomes 2x, beyond that point, atmosphere do not have a theoretical predictability. You often come across that यूरोप में तो बहुत बढ़िया forecast होता है, अमेरिका में बहुत बढ़िया होता है, हमारे यहाँ क्यों नहीं होता है, हम वो 15 दिन पहले बता देते हैं. This is tropics. The predictability in tropics is very limited. It's 5 days, 7 days in winter, and so on and so forth. Because here it is all driven by radiative forcing. But in extratropics, it is 2 weeks, more than 2 weeks in some season. So that's where the catch is. The third form is the integration, both in space and in situ. Because as I mentioned, the in situ observations are very limited. For example, to mention that in India we have about 500 observatories which are manual. We have about 40 stations which take vertical profile of atmosphere, releasing balloon and now, but these are again, you have to fill the gaps. So you need satellites, you need radars. But again, satellite is not observing temperature, not observing humidity, not observing wind. They will only observe spectral properties of the body which is emitting radiation. So it is measuring radiation, radiative properties. And from this, you have to have algorithm to translate this property into temperature and so on and so forth. Again, thank you very much. Again, so when you do this, huge amounts of error goes into the system. So again, a big challenge as to, and therefore, I won't share the statistics, but only 20% of the satellite derived meteorological information are found to be good to assimilate, to be assimilated into model. You have to take extremely good care to churn this observing. Sorry. And by the way, today, the kind of, the volume of data which we are churning is about 20 20 terabytes, huge information. So the kind of computing power you need, imagine. So therefore, you need supercomputers. And then you have to have a foolproof mechanism for eliminating all this error. Again, very important thing. Our predecessors observed weather in 1860s, 17 so, 19 so, and you use time and again. So the taking observation, because you observe once and use many times over the period. So you have to have the metadata, you have to have so many quality tags, and imagine the kind of the data processing requirements over the period which are needed for using data in later point in time for various applications. Now coming to the observing systems, we in India have about 16 Doppler radars, then number of automatic weather stations, automatic rain gauge, surface observations, which as I mentioned, are manual. Then at every airport we will have airport observatory, then number of other observations, and also upper air radio sonde observations, through which we release the sonde attached to the balloon and who take the vertical profile, go up to 35 kilometers and send us data on the real time. And by the way, the time criticality. Now, we run the model twice a day, 0 UTC and 12 UTC. Now, to get this data from across the globe with the minimum time lag. And so we do this exercise twice a day with a window of about 8 hours. So from the time it is observations recorded in any part of the globe, has to come and cleaned and then assimilated, and then you run the model. So this is what the time frame. These are types of observations I won't dwell into. Just to give an idea that you have to have a varied type of observations, not only atmospheric observations, but also observations from oceans, which define the ocean surface conditions, also the land surface processes, which are very critical. So you need to have what type of vegetation, what type of soil, how much flux it must be sending into atmosphere. All these algorithms are set into the models to really define the initial conditions and how they have dynamic influence in dynamic mode in the further processes. We are one of the prime user of satellites, and also again we have a consortium group of meteorological satellites, and all countries including Europe, EUMETSAT, America, Japan, China, India, Australia, we are member, and we have our INSAT series of meteorological satellites, and a year back we launched INSAT 1 3D, and that was made operational on 15 January this year. This has on board both imager as well as sounder. Earlier satellites, Indian satellites, had only imagers. They used to take images in different wavebands. But now here we have payload which do a vertical profiling of the atmosphere. It gives a vertical profile of temperature and humidity, and that really gives us a significant handle in better defining the initial conditions. And these are the type of spectral bands we have: visible, shortwave infrared, middle infrared, water vapor, thermal infrared, and infrared 1 and infrared 2. And the resolution which we are able to resolve in visible and sphere, we have about 1 kilometer, and in infrared about 4 kilometer, except water vapor, which is at 8 kilometer, and you don't need that very closely water vapor at that level. Also, since we need to communicate these observations in real time. So therefore, you have to have a dedicated meteorological telecommunication system to cater to this data flow. And this is again the flow. We at India is the regional telecommunication hub for the World Meteorological Organizations, and there are 8 prime hubs, and they talk to each other. And so each country will have to have a protocol at what point in time they record observation, then they code the observations because it has to be coded, and then they transmit observations, then it is pooled somewhere and then again shared. And this is the kind of network which we have, and everything is almost near real time. Now coming to predicting weather. So this is how we really take observations and define the initial conditions. This is the segment which define all these observing systems which we talked, and then there is the global data which flows into the system to define the initial conditions, and thereafter we run the numerical models, and we extrapolate both in time and space. And let me tell you, there are different models to address to different temporal ranges. For example, if we are talking in the nowcast, which is few hours, then ball game is different. When you are talking medium range, ball game is different, because the level at which you treat the physics and its manifestation and atmospheric process are different. And when you go as in a longer time series, then you compromise so many things. Then you talk only in terms of reference normals. So as you extend the temporal range, the criticality of the dealing at the process level also changes. These are the models which are now under operational use. And when I say, because medium range 3 to 10 days is our working hours, that is most desired level. Presently this is again, we define the model as T574. That means that it is a horizontal grid resolution of about 22, 23 kilometer, and level 64 means the vertical levels of atmosphere 64s. And we assimilate the observations and run the model twice a day, 0 and 12 UTC. Again, there is one very interesting problem in modeling. No model will give you a good forecast all the time at all the place. Some models will have some strength and some weaknesses here and there. And so therefore, what we do is we try to capture the best part of the model. Best part of the model, and then how to do that? What we do is we assess each model and see as to how it has behaved in the recent past. Do an online verification of their forecast in the recent past, calculate scores, and adjudge as to what is its strength over a particular space, say for example Delhi or Rajasthan, blah, blah, blah. And accordingly, all the models, we make use of 5-6 models and capture the best skills through various numerical and dynamic techniques, and generate multi-model ensemble forecasts in order to further eliminate the error. As I mentioned, for short range, different models are utilized which have more intense physics, more intense land surface process definitions, and so on and so forth. And for nowcast, there are different models. These are the models which we are presently handling. The operational forecast bulletin. When I say operational forecast, that has a different connotation. That means we have standard operating procedures. In weather forecasting, we have a protocol of right from observations to communications to analysis to prediction, everything, and then there is a specified format for each forecast. And these are the types of forecast which are issued, which is varied forecast, and is for different purposes and for different temporal ranges. Because for aviation, you need entirely different forecast. There you need, at the time when aircraft is likely to take off, he has to decide how much weight he can take. That will depend on the temperature. So he will need what is the current temperature. Here he doesn't need much of the forecast. He will need the current meteorological observations. Then he will also need route forecast, destination weather, and more importantly, what is the shear. And at en route you find a lot of turbulence. So you also have to identify as to what are the pockets where you are likely to encounter the turbulence. Though the aircraft will have a radar on board and they are able to see, but still you give them guidance. And the landing is more critical than takeoff, and the visibility is very critical. I'll touch upon in one of my future transparency as to what we are doing because these days you might have noticed that there are very least diversions. So, and we have done a good job on that direction. So this is what I talked, that we take different models and we generate the whole focus. A few years ago, हमारा होता था कहीं कहीं बारिश होने की संभावना है, राजस्थान में पूरा प्रदेश में, gone are the days. Now we give location specific forecast, quantitative forecast, and day 1, day 2, day 3, day 4, day 5, and quantities of all the meteorological parameters, because that is the paradigm shift. And not only that, the earlier our skill of issuing forecast was only in the short range. After the National Center for Medium Range forecast came into being in late 80s, then we started this system, and then we started quantitative forecast, first 3 days, then 4 days, 5 days, and then outlook for another 2 days. But very importantly, now we have also developed systems for extended range forecast. And last couple of years, our Institute of Tropical Meteorology developed that, and it is now semi-operational. And we are giving this input to agriculture community, where a pentad-wise forecast, this is pentad 1, that next 5 days, then next 10 days, next 15 days, next 20 days. And let me share with you, it's a pretty good skill. And we are able to capture the active and break cycles in the monsoons, which was a big challenging task few years ago. But today we have a handle on that. So also we have set up a network of radar stations, and radar will give you instantaneous observations on the severe weather, particularly cumulonimbus clouds and so on and so forth. And then the next challenge was to generate the nowcast, which we started last year, and so now we are giving about 140 stations nowcast, which is for about a couple of hours, though it doesn't give you very long lead time, but that also is very required, and an informed user really make use of this information. And for that, we assimilate radar observations, run specific models, and generate the forecast. These are some of the kind, is how it is moving, and more importantly, that the immediate past movement and intensity of the system, how it is increasing or decreasing, is very critical and are really captured. So persistence also is one of the important component in dishing out this kind of forecast. So on the web page, if you visit, you will find that about 140 stations for a better and easy comprehension at a snapshot. You will get this kind of all India nowcast as to where the CBs or the severe clouds are there and what are their level of intensities. Now I would just touch upon the skills, because that is the common question which we are confronted with often. And these are some of the skill scores. This is false alarm rate, which is significantly declined. This is missing rate, critical success index, and so on and so forth. So point I want to make is, because of all this development, there is significant improvement in the skill. And one of the tool, where, as I mentioned, that if there is an improvement in the model, there is improvement, there should be improvement in the skill of the forecast. And a few years ago, we used to have a lower version of the same type of model with a horizontal grid resolution of about 37 kilometers, 35 to 37 kilometers. And this is one example that how much jump in the percent correct forecast. I mean, this is the correlation coefficients for different seasons, which are depicting that with the improved model operationalization, you really get a significant improvement in the skill. And we are now embarking upon for our next generation model, which will further improve the skill of the forecast. But let me submit that henceforth the improvement in the skill is becoming more challenging task. These are some of the verification scores for the rainfall forecast at a location specific. And let me submit that this is day 1 forecast and this is day 5 forecast. And yes, no forecast, if I talk, here it may be 88% for a given location, day 1, but substantially in day 5 there is 82%. So over the, as you increase the temporal range, there is a decline in skill, but it's still very usable, more than 80% plus minus. So it's some different stations and different scores. This is, again, I'll touch upon this. This is the fog forecast, and it gives the number of flights which are diverted as per Cat 3 airports. And there is a substantial fall in the diversion rates. And in order to do that, we have visibility instruments which are set up at different parts of the runway, and then we run our specific models using the meteorological and other aspects, and then generate the forecast. Just to give you statistics, that the last 3 years, what is the improvement in our skills? The false alarm rate has reduced by 56%, missing rate by 45%, probability of detection increased by 56%, and so on and so forth. So that is a kind of improvement which is now happening in the recent past. And I'll just touch upon one important service which are rendering, and that is the cyclone forecasting. And in order to, the cyclone, basically it's a 5-step process, and we have to predict cyclogenesis, that what is the likely chance of getting a cyclone formed, and then what is track forecast, intensity, then also predict if there is a rapid intensification or rapid decay of the cyclone, and particularly at the time of landfall, how it is going to behave. Because when it comes in a close contact of the landmass, because of the friction and then temperature and humidity differences, there may be cold air entrapment. At times it gets accentuated, at times it rapidly decays. And so, and that is where it is most critical, because the life and property is at a stake. And let me submit that till 2009, we were able to give forecast only for 24 hours. And 2009, we started giving 72-hour forecast. And last year, we started giving 5-day forecast. 5-day forecast with as good skill as 24, or rather at times the better skills. These are some of the skill scores, paucity of time I will not dwell upon. These are the 5 cyclones formed last year. And all 5, these are the observed and predicted tracks 5 days in advance. And see, there was one cyclone, this was Cyclone Madi, which was moving like this, took a loop and came down and hit the Tamil Nadu coast. This loop was predicted, I think, 4 days in advance, if I remember correctly. And importantly, while Cyclone Pilin, which hit the Odisha coast, we asked evacuation for 5 districts, and the confidence, earlier forecaster would say that Andhra se Bengal tak kar do. Gone are the days. We said 5 districts, and that really enabled the state governments to concentrate the evacuation process. And more than 1 million people were evacuated with all manpower.
This green thing is predicted?
This is cone of uncertainty. This is cone of uncertainty. Predicted one is the red, and that the black is either way, maybe, I don't know, I'm not able to see. But important is that for other cyclones, like one hit the Andhra, one hit the Tamil Nadu, we didn't ask for any evacuation, because we were confident. One cyclone was very severe cyclonic storm when it was on the ocean. But we knew that when it's coming closer to the coast, there is going to be colder entrapment, it's going to weaken. And then we told the state governments not to be panicky and not to evacuate. That need guts. That need guts. So we are at that stage, and more often than not, if you do that, you're not noticed. You are not noticed. But really, and That is the kind of. That's it. That's it. I'll just cite an example that we are now trying to even capture as to what are the, because the focus is more given on impact-based forecast. What sector of economy is likely to be impacted, and try to focus on that and try to inform the impacted or likely impacted community. Like, for example, when the Pilin, the Odisha cyclone, the Hirakund Dam, whose capacity of 630 feet was up to brim. So we just took the data and we found that 629 point something, maybe 629 something was the level. And then since the forecast was that it is going to be extremely heavy rainfall, and so we asked government to open the gates. And of course, I had to intervene at the apex level, because normally these decisions take longer time, and then you said, open the gates now. And then we operated through cabinet secretary, and immediately gates were open, and water reservoir level was brought up to 621 feet. And 11th, when the rainfall started, we again asked them to now close the gate. Because otherwise, down the stream, if the Mahanadi is full, and then it might. Now, if this alone would have been done, despite of correct forecast, thousands would have marooned, I tell you, despite of correct forecast. So this is how you manage, how you communicate, how you, it matters. So so also is our seasonal forecast for monsoon. Now, we issue twice, April and June, and also midterm July forecast, and finally for August also we issue forecast. More often than not, the skill of this is being criticized. But again, one has to see, as to we are talking 4 months in advance, but there is significant improvement in the skill in the recent past. And this particular year, we told that it is going to be below normal. Now, there may be magnitude of error may be different, but to say that monsoon is going to be below normal, you really need. And the response of government is phenomenal, I tell you. Phenomenal. And we are so prepared from all aspects to combat this. So I'll just, also we're giving onset of monsoon forecast. But so the point I want to emphasize is that this improvement in the skill have come through better understanding of the atmospheric processes, better observing systems, better communication systems, better analytical tools, better models, faster computers, skilled manpower, and better information dissemination system. Now, just to touch upon the services, we of course touch upon all the spheres. Weather touch everybody. So, but we have organized services for certain sectors, less organized for some sectors, and not organized for rest of the sectors. But we keep information on our web pages and other information dissemination systems for making use of them. But let me tell you that our aviation services are very good, because as per ICAO protocol, that is International Civil Aviation Organizations, you can't take off or land without weather. So weather it determines, and therefore then the precision level required for aviation forecast is highly demanding. You can't afford to be wrong. But of course, you do only for half, because the time period for the flyers are lesser, so fortunately we come correct. But so half-hourly interval you have to issue the METARs and species, and there are very different protocol. And second is agriculture, hydrology, cyclone, and so on and so forth. And these are, but at least 30 sectors are there, which are including defense and so on and so forth. And even for mountaineering, pilgrimage, we have a special forecast for Amarnath Ji or Kumbh Mela or Char Dham, etc. And so, an important thing is that earlier we were really caught unaware of extreme weather events more often than not. Now we are able to capture them more often than not. Even last year's Uttarakhand we captured very well. We captured very well, and this year also, 16th of July, we forewarned the state governments beforehand, and see the difference. Earlier they really couldn't respond to that, and this time they responded. Yatra Roka, we could really save a lot of. Hydrometeorological services, rainfall monitoring is a Herculean task. Monitoring rainfall, and end of the day, you have to generate statistics for today's rainfall. Real time, believe me. I mean, and you ask any other sector, agriculture, water, nobody will be able to generate this kind of data on real. I challenge. And you will see IMD's web page every day, dynamically it is updated. So taking all these observations, processing them, generating statistics, and Herculean task. Reservoir management, input for flood forecasting to CWC. CWC has the mandate to issue the flood forecast, but because the rainfall is the prime input, so rainfall prediction is given to Central Water Commission, and then design storms projects, because that is more on the rainfall climatology and statistics, which are used for a variety of purposes, including insurances, agriculture insurance, and so forth. One of the important service, how much time I have now? Okay, thank you. Is Agromet Services, where we have a very organized service being run in as close association with the state agricultural universities and the state and Indian Council of Agricultural Research, where we generate weather forecast at the district level, and we have planned to start for block level, now 6,000 blocks, communicate to this agriculture community, and set up a mechanism to translate this meteorological information into what action farmer has to take, whether he has to put seed or irrigate, not to irrigate, apply pesticide, and do what intercultural operations. And then disseminate this information to the farmer, which is again a stupendous task, and we have given a lot of emphasis on the information dissemination. Today we are sending through mobile to about 5.4 million farmers who are subscribing this information. And when the Obama visited India, he saw this system, and while he addressed the joint parliament session, he made a specific mention of this, that he was happy to learn this development happening in India. Information dissemination, and at this level. And so we deploy all mass modes of communication, IT, and so on and so forth. Again, as I mentioned, extended range forecast, this is more in now semi-operational mode, but we will make it operational. But important thing, there was an economic impact assessment survey done by National Council for Applied Economic Research, and autonomous body. And they have found that because of this service, there is estimated 10 to 25% economic benefits which are realized by the farmers, 10 to 25%. Imagine. And then they have worked out the statistics that annually 50,000 crore are being realized, but the outreach is still a big problem. We are not able to penetrate. Our outreach is very poor, and so that is where segment which we have to concentrate to enhance the outreach. And then if you really do that, then the things would be much better. The future plans, first and foremost, is to further improve the observing systems, better satellites, more radars, more surface, and then aircraft reconnaissance, particularly the severe weather, cyclones, and the cumulonimbus clouds. The thunder and lightning are the biggest killer. Annually, they are the biggest killer. Thousands of people they are killing. We really have very less clue on that. So that's where we need to better observing systems, improve data assimilation. Data assimilation is very involved task, as I mentioned you earlier. Then integrated research. Now monsoon mission, Dr. Rajivan is the charge of that. We are really trying to better understand our monsoon, and it's a global effort. We invited the global meteorological community to participate in this process, to really do a focused R&D for better understanding the processes. And forecast improvement, as I mentioned, that we are presently at the spatial resolution of district. There are about 650 districts, but we are now going to block level forecast. And that will be a phenomenal leap into this. Extended range forecast, make it operational. The seasonal forecast, we have now coupled models, because in that temporal range, the memory comes from the oceans. You might be hearing El Nino, this, that. These are oceanic temperatures which are having a great influence on the atmospheric processes, and vice versa. So you therefore need to have better handle on the oceans, and then couple ocean models with the atmospheric models, and that's where we are now presently working. And better service delivery and information dissemination process in various sectors of operations. Thank you very much.
What about jet stream? regarding the jets.
Yes. Jet stream is it's a very good question. Phenomenal of the thermal gradient, and when you travel from Asia to Europe, you cross the jet stream. These are the westerly winds, and with height, their wind speed increases, and there are pockets of very severe, intense speeds which are going up to 200 knots at times. Yes, so, but they are very well organized, and it's
We have a western cyclonic disturbance in the northwestern part of India. Western cyclonic disturbance. So that needs to be predicted, that needs to be monitored. Because of that, we get sometimes unpredictable rain, cyclonic thunderstorm. So have you also worked on in that particular area?
fortunately, as I mentioned, that these are basically extratropical systems who have better predictability, and these are kind of frontal systems, because the European air or land mass is cooler, and then and when it confronts meet with the warm and humid tropical air mass, the fronts are generated, and it is a unidirectional movement. It moves from west to east, so therefore it is easy to predict, well behaved, and once formed, it will not dissipate easily. Unidirectional, एक बार बन गया, चलेगा 10, 12, 15 दिन, then आपको तो you have to capture how it has moved in the recent past. So our prediction skill in winter, you might have noticed, is more than 95%, yes, no forecast, more than 95%, because of this.
That is the same reason why we Americans and Europeans say that their prediction is better. Because they are influenced by this kind of weather system, which are very systematic, very easy to predict.
Whereas you are saying that tropical climate changes, weather changes are much more frequent or fast developing, and in the temperate regions it is more stable or less predictable, less changeable. But experience shows that if you go to Europe and all, their weather changes very fast. I mean, you are never sure. Whereas in India, if you are in summer, the summer is continuing for 2 months. There is absolutely no change. I mean, you need not take any umbrella during that time. Or you can dress
I
whatever way
didn't
you
say
like.
that. The predictability of change is better. Predictability of change is
but
better.
it is changeable, more changeable.
Yes, yes. Please.
थैंक यू सर
Yeah.
सबसे पहले तो बहुत बहुत धन्यवाद कि आपने इस देश के बारे में, देश की छवि के बारे में इसको इम्प्रूवमेंट किया और कैसे हम इसको इम्प्रूव कर सकते हैं, आपके लिए बहुत बहुत धन्यवाद. माय नेम इज कुमार फ्रॉम CST as a science report. We start a new project in our ADRIC, means Advanced Industrial Disaster Risk Reduction and Information Center at Valor in Rajasthan. In this connection, I have two questions, sir. First is city development or air quality forecasting or urban development or power energy forecasting is essential for the city development, because more impact of the climate in agriculture is very high. Recently, Prime Minister announced the Kisan channel for the improvement of the farmer. Now they forested around the radio stations. Now question is at a local level, whether taluka level or a district level, there should be some district level proper R&D center to make a district forecasting in a good way, better way, weather forecasting, climate forecasting, power, energy, environment, and urban development. One. Another is,
Can I respond to this first?
Another
Otherwise, I'll
question
lose
is-
track of your
no,
first question.
Another question is, there are every day.
Let him respond. Let him respond. Let him answer that. Yeah.
This is a valid point. You need to have at a better granularity. जहाँ तक फोरकास्ट का प्रश्न है, वो 2 या 3 स्तर पे की जाती है. पहला, क्योंकि जो जिस तरह का इंफ्रास्ट्रक्चर चाहिए, आपको मॉडल रन करना है, वो एक जगह होगा. फिर जो रीजनल एस्पेक्ट्स हैं, वो रीजनल लेवल पे किए जाते हैं. लेकिन ख़ास तौर से जो आपने बात कही कि ज़िला स्तर पर आपको एक इकाई को स्थापित करना पड़ेगा जो एक तो उस फोरकास्ट को फाइन ट्यून करे और फिर जो है यूज़र के साथ लिंक करे। बिल्कुल सही है। तो हमारी पृथ्वी विज्ञान मंत्रालय की जो 12वीं पंचवर्षीय योजना है, जिसमें कि हम ब्लॉक लेवल फोरकास्ट इशू कर रहे हैं, हमने ये भी तय किया है कि जिला स्तर पर एक कृषि मौसम इकाई, जो अभी हमारे केवी कृषि विज्ञान केंद्र हैं हर जिले में है, और वहाँ पे ऑलरेडी 4-5 कृषि वैज्ञानिक हैं, वहाँ पर हम एक मीटरोलॉजिस्ट लगा करके इस इंफ्रास्ट्रक्चर को एक संपूर्ण आयाम देने का प्रयत्न करेंगे, जो कि उसको ये फोरकास्ट दिया जाएगा और वो फिर बाकी कृषकों और बाकी लोगों से जोड़ेगा।
थैंक यू सर। दूसरी जो बात थी जो आपने बताई थी कृषि विभाग, क्योंकि अलवर में एक कृषि विभाग का ऑलरेडी है और दूसरा भी बांसुर के लिए सैंक्शन हुआ और चल रहा है, उसी में इसको अगर डेवलप करके और एक मॉडलिंग बना दें तो मैं कहता हूँ अच्छी सर्विसेज होगी, रेडियो भी होगा।
बिल्कुल सही कहा, हम उसी से जोड़ने का, उसी पे राइड करें
और एक बड़ा नेटवर्किंग करके तो हम फार्मर्स को ज़्यादा इंफॉर्मेशन दे सकेंगे और प्रोडक्टिविटी बढ़ेगी हमारे देश की।
जी, थैंक यू सर।
Any other questions? Yeah. Yeah. Yeah, please carry on.
Dr. Rathore, I'm from an aviation background, and I used to be in charge of operations, airports and air traffic controls. My question is, the development of equipment, like you mentioned category 3, fog recording, also with RBR equipment, etc., is this going to be extended into category 2 and at least category 1 areas, so that as traffic grows, you get more information for people? That's one. Secondly, automatic data collection. And I've worked for the UN abroad, and they have so many things which are hygroscopic, viewpoints, temperatures, wind, etc., automatically. There's no Met Department personnel. Can that be increased in India?
Thank you for a very good question. As far as visibility equipments are concerned, so far we were dependent only on the imported RVR equipments. Now we have a CSIR laboratory, National Aeronautical Laboratory at Bangalore. We have been working very closely for development of indigenous RVR equipment, Drishti, and it is in news these days. Runway visibility range. Runway visual range. And so you have to measure as to what is the visibility.
How far you can see.
Yeah, both ends and also middle part of them, so at 3 parts. So this has now been indigenously developed and deployed at IGI, Kolkata, Lucknow, 3 airports already. And now we have prepared a plan for zero diversion, and we have identified 20 airports which are prone to the low visibility, and we will deploy all this equipment before this winter, and to really help the aviators in a much better way. Second question is regarding automatic. Yes, we are deploying now them, and also because helicopter operations are coming up in a big way. And we have set up a couple of months back one automatic systems which not only record but also communicate, transmit, so a pilot can fetch in the information when he come in the 50-kilometer dia of the equipment, he will get the meta. So temperature, wind, automatic, no manual intervention. And we are going to launch this at Vaishno Devi, maybe middle of this August, maybe 16th, 17th. And then this is again indigenous development. And then we'll replicate in most of the Himalayan states where the helicopter operations are much intense.
We have more than 1,000 AWS stations now?
AWS, we have 675 automatic weather stations and 1,206 as on date automatic rain gauge, which also has 4 sensors: temperature, rainfall, wind, and so on. And we have more planned for about 2,000 such stations. Yes, please.
There was a time when it was said. Is it okay now?
Yeah.
There was a time when it was said that God made economists to make astrologers feel good. The kind of unpredictability that these people handle. Now, now I think you are again in a similar category where God made meteorologists to make everybody good. Very true. But imagine what happened in China during Olympics. They were expecting rains. Not that they only predicted rains, they even avoided it for 7 days. How does that happen?
First segment of the question is very interesting because in weather forecasting, you deal with uncertainties. And the whole idea is how to minimize uncertainties. I mean, you will never be able to predict 100% correct. Never, never, never. So only thing is, in some segments, you will be able to minimize this uncertainty to a great extent, some time and some weather situations to a very lesser extent. That is what we are dealing with. So therefore, the longer the time range, the cone of uncertainty increases. And therefore, what you do is, when you talk in nowcast, you talk very precise. When you are in medium range, you are again quantitative. But in further, you say probabilities. So uncertainties are directly linked to probabilities. Thanks for putting word. And the second question was? China. Weather modification as and what you listened was much of propaganda than a real science. That's it.
Thank you for letting me ask the second question. This is not really related to observations and forecasts. A little bigger issue. May I ask a question on global climate change?
Sure.
Which of course is, attracting the attention of the whole world, though not with that much of seriousness perhaps. Tell me, what exactly is the present situation? Global climate change is not felt on a daily basis or anything. What we perhaps see is the incidence of a greater number of weather extremities, sometimes very heavy rains, very heat waves. Is this really true, or we just think that it is happening like that? Are you seeing any data change, that is, on a global scale, that these, these extreme weather conditions are happening more and more often?
First and foremost is that global change has always been occurring since the day Mother Earth separated from Sun. Had this not been happening, we wouldn't have been here. Number one. It is again a constant process. The change which we are talking is a very recent phenomena after the industrial era. Now, three things are observed. First and foremost, there is a significant alteration in the composition of or the constituents of the atmospheric gases, for reasons you know better than me. And since that is there, that is changing the radiative properties of the Mother Earth system. And therefore, the warming is also a fact. It's a fact. Now, the magnitude may be somewhere less, somewhere higher, and so on and so forth. And the third thing is, if it is warming, it will have two influence. One is the sea level. Snow is definitely to melt, and sea level has been rising. And coming to the rainfall, yes, two things. First, if Earth is more warm, 2/3 is ocean, there has to be more evaporation. So therefore, theoretically, there has to be more rainfall. But this is not uniform, unfortunately. It may be happening more on the oceans and less on the land, and it's very complex, very complex. But because of change in the energetics of atmosphere and the thermal property contrast between ocean and land, leading to one important thing that you might have noticed, that more and more rainfall is occurring in less and less time. Number of rainy days are reducing, intensity is increasing. So that's what you experience. I think I answered your question. Yes, madam.
Yeah, before that, please.
Oh, sure.
He's waiting for a long time. Part of my question was related to actually.
Can you introduce yourself? Sir?
So I'm Sanjay Jain, and I teach physics at the University of Delhi.
Okay.
So my question was also about climate change, and I want to know if there is anyone in the country, any group in the country, maybe your organization, which is thinking about the impact that climate change is likely to have on India within different parts of India, and how that would be different from other parts of the world. Is there any group which is thinking about the differential impact of climate change on different parts of the world and within India?
There are 4 components. Component number 1 is to observe weather, and because as I mentioned that climate is a long time average, so observation with synthesized climate is the domain of National Weather Service. We do that. The second component is the science part of understanding the climate change and prediction of that is our Ministry of Earth Science again is responsible for that, and we have a climate change center which is now housed in the Indian Institute of Tropical Meteorology, Pune, which do the science part of it. The third component is impact. Impact is a different ball game, and therefore you need to have a sectorial assessment of the impacts. And the largest impacts comes on the agriculture sector, because and then we are very concerned about that also, then water sector, then health sector, so on and so forth. And therefore the agriculture, in the Indian Council of Agriculture, there is a national mission on the climate change, Government of India, there are themes, and then Ministry of Agriculture, Indian Council of Agricultural Research has been mandated to carry out understanding the impacts of climate change and also work out a strategy as to how to develop, how to respond to that, and so also water sector, health sector. At global level, we have a global framework for climate services that again came as a specialized agency of UN by WMO, as Dr. mentioned, of which I am a vice chair. And earlier there was intergovernmental panel on climate change, which looks after the observation, and then but this is more targeting towards service component of that. And then it is in infancy. We have started only last year, and then we are to develop the national framework for climate services and how to factor the climate information in your decision making process in that temporal range is the likely thing for tomorrow.
So my question is, like, we monsoon region, Southeast Asian, we are in the monsoonal zone, and here we face the pressure system change. One, the jet stream, which swings summer, winter, and the other southern oscillation, which also swings. So is the meteorological department really working on these 2 aspects to understand the temporal and the spatial variation of rainfall and the arrival of the monsoon, which is always uncertain? Can we work on this, which can help again the farmers and also otherwise? So this aspect, what is the work being done by the meteorological department?
Actually, monsoon is, I consider, the most challenging and most complex research problem. It's not only IMD or Ministry of Earth Sciences are working, there are a host of IITs and Indian Institute of Science and other universities who are working on it, and not only nationally, because America or Europe has equal interest in the monsoon, because if they are not able to simulate monsoon, they can't predict their weather. Weather is global commodity, and therefore it is in their interest, they want to really simulate. So there's a global fraternity who are concentrating on understanding, and there are a lot of missions which are being launched.
What have we done in our country?
We have, as I mentioned, now we have launched the monsoon mission. And monsoon mission is a integrated, coherent program funded by Ministry of Earth Sciences to get a directed research on various components of monsoon and assimilate that research output into operational models which can have a better forecast system, so end to end.
Yeah. Any other questions or suggestions? Yeah.
सर थैंक यू. मेरा एक सजेशन है सर. सजेशन है कि जो अभी ग्लोबल इंफॉर्मेशन सिस्टम सेंटर्स हैं जो वर्ल्ड लेवल पर काम करते हैं, अगर हम अपने देश की बात करते हैं, मैं राजस्थान को बिलोंग करता हूं.
मैं भी राजस्थान से.
राजस्थान को बिलोंग करते हैं. राजस्थान में इतना डेजर्ट एरिया भी है, प्रोडक्टिविटी है. जब तक किसान को बराबर इंफॉर्मेशन बराबर नहीं मिलेगी और उसको मिलने के बाद में उसका एप्लीकेशन नहीं कर पाएगी, अडेप्टेशन नहीं कर पाएगी, तो हम उसको इंक्रीज नहीं कर पाएंगे।
ठीक।
तो मेरा कहना है कि ऐसा कोई स्टडी हो कि हम इन्फॉर्मेशन फ्लो करें, किसान को अडेप्ट करें और वो प्रोडक्टिविटी में चेंज हो जाए, और जिससे कि हमारे किसान भी उसको फायदेमंद हो, मार्केट भी डेवलप है और इकोनॉमी में चेंज हो जाएगा। अभी जो प्राइम मिनिस्टर का गोल भी है, तो मेट्रोलॉजिकल डिपार्टमेंट, सो मेनी एनजीओज भी हैं, कृषि विज्ञान केंद्र भी हैं, यूनिवर्सिटी में वर्क करते हैं, लेकिन फिर भी प्रोडक्टिविटी नहीं इंक्रीज होती है एग्रीकल्चर। वाई? तो क्वेश्चन है कि व्हाट शुड बी द पैराडाइम शिफ्ट, मे बी डिस्ट्रिक्ट लेवल, मे बी तालुका लेवल और मे बी स्टेट लेवल।
मूल रूप से सूचना की गुणवत्ता का सुधार एक प्रश्न है और सूचना का विस्तारण दूसरा प्रश्न है, और किसान जो एंड यूजर है उसकी क्षमता का विकास करना, उसको कैपेसिटेट करना कि वो सूचना का हाँ प्रयोग कर सके, और वो ग्रास रूट लेवल पर ही संभव है। और आपने बिल्कुल ठीक कहा, आप बहुत अच्छा कार्य कर रहे हैं, आपका एनजीओ ऐसे ही खड़े होंगे तब बात बनेगी, अकेले हमसे नहीं होगा। रामा,
मैं 2 साल से इसी पर वर्क कर रहा हूँ, क्योंकि क्वेश्चन है कि सब कुछ है हमारे पास,
ठीक,
लेकिन हम उसको अडेप्टेबिलिटी में नहीं कर रहे हैं। जो अडेप्टेबिलिटी में, तो काउंटेबिलिटी में नहीं होगा, प्रोडक्टिविटी में नहीं आएगी।
ठीक बात।
I noticed from your table that there are larger number of non-governmental rain gauges than automatic rain gauges, and probably you not listed the manual rain gauges that you have under the department. I would like to know how many manual rain gauges still exist, and why, who runs these non-governmental rain gauges which are such a large number. And secondly, of late we have seen the emergence of private meteorological services, and how do you plan to integrate with them in some sense, or because they might occasionally also produce kind of information which may not really coincide with what the meteorological department is trying to say. So the public could be at a loss to understand which is the correct one, which is the wrong one. Yeah. So how do you plan?
First thing is about the non-departmental rain gauges. Though they are non-departmental, but there is a quality check process. These are identified. We give the rain gauge, we do annual inspection, we pay these observers, we train them, and so
It's all run by state government.
it's run by state governments and so many mechanisms.
University department also.
Right. There are so many mechanisms. There are so many mechanisms. And over the period, maybe we'll phase out with them once we have better sound our automatic systems. Coming to the second question, yes. First and foremost, we have to graduate ourselves both as National Weather Service and private player. Nowhere, in US also when they started coming up, there was some confrontation. But then they have a policy guidelines. These players, there is enough room for private forecasters because they must concentrate on various applications, selected clientele. They should never venture into creating scarce. जैसे इस बार एक मैं नाम नहीं लूँ, कहा कि इस बार 60% डेफिशिएंसी होगा। अरे यार 30% से ज़्यादा मानसून में कभी हुआ नहीं, तुम आया जाए कुछ भी बोल देते हो। मीडिया भी छापता है, आप नहीं छापते बट छापता है, और बड़ी चैनल्स पे चलता है, और वो हमको बिठा करके उसको बिठा करके दिखा insensitisation. Unfortunately, there is no policy, and I should not be commenting because it's a democratic nation, but this is not the way we should be doing it. किसी को there is enough room. National Weather Service should do forecasting, and they can do tailor making for various applications. That is where absolutely.
So, I mean, there should be some kind of regulatory regime that should
Will come because now they have come up, so there is now need felt for the regulatory mechanism. Will come in due course of time, I'm sure.
Ramachandran is a very sensible person. He doesn't write.
He doesn't. I know Rama. Huh?
News is not read by FMs.
Yes,
It comes only from all India radio. So that's how something will happen.
right, true.
What is this company called AccuWeather? I mean, they are forecasting.
AccuWeather is a US company. It's a very good group of forecasters. There are about 200 plus meteorologists, and it's run by meteorologists. And let me give you this, since you have raised this, AccuWeather has come to us. And often people say, "Arey, hum AccuWeather dekhte hain, bahut badhiya hai." Now, and we have also launched Android applications by IMD, which is not so popular. गवर्नमेंट सिस्टम्स जो होता है, बट होगा. बट सो AccuWeather, what they did, they're giving they're very good mechanism. What they did, they assessed the skill of the forecast issued by IMD vis-a-vis their forecast, and they found that they are way below the skill of IMD. So they have come to us, then they are asking to join hands with a common logo that IMD can have logo, and then because we have better information, so we have no issue. But only thing is they are making money. So I told them, Baba, you come with a business model. Business model. So we are working at that level. So maybe going to take some time. But once there's a business model, then they don't want to share. But it will come, I'm sure, because there is a significant need for both of us, because it's a symbiosis.
They have no accountability.
They have no accountability. But once IMD logo is there, that means product is generated by us.
What is your need, sir? Symbiosis.
Oh, because
दोनों की need होनी चाहिए.
हाँ, हमारी need ये है कि they have very wide outreach. Outreach, very good software distribution mechanism, very good.
Dissemination is very good.
Very good. Yes.
I have weather chart. Something called weather chart.
Say.
Okay, if further no questions, we will all
Thank you very much. I really enjoyed the discussions, and
Also,
thank you very much.
Thank you all of you for nice interaction. That is more important. Thank you very much.
Thank you, sir. Very good talk. Excellent. क्या मुझे तो पता ही नहीं था कि